Hello everyone, today we're going to be doing some weak induction. So the problem that we're trying to solve is to prove using induction that 9 to the n minus 1 is divisible by 8 for all n greater than 0. In order to prove with induction, we must have a base case and an inductive step. So first we're going to start off with the base case here. Now thinking back to the problem, since n must be greater than 0, our first instinct is to try 1 as a base case, which, substituting into the equation, returns 8, which is divisible by 8, so it checks out. Now, we're moving on to the inductive step. For the inductive step, first we want to formulate a claim. In order to formulate this claim, we're going to create the predicate p of x that states n to the x minus 1 is divisible by 8. Using this predicate, we can now formulate an expression that represents the problem. For all k, that exists in Z, which represents the subset of integers, and k is greater than 0, implies p of k. So this states for any integer, or for any number k that is an integer and is greater than 0, 9 to the k minus 1 is going to be divisible by 8. So now we're moving on to our inductive step. For the inductive step, we have an inductive hypothesis, which is where we assume that for k, so n to the k minus 1 is divisible by 8, which we're going to denote as 8 times an arbitrary integer m. So we're now going to use that to prove k plus 1, or n to the k plus 1 minus 1 is divisible by 8. And we're going to note that as 8 times another arbitrary integer m2. And we can now expand that equation above to nk times n minus 1 is equal to 8 times m2. Now if you see, we could substitute in nk from the inductive hypothesis and get 8m plus 1 times n minus 1 is equal to 8m2. Now by foiling out the n, you get 72m plus 9 minus 1 is equal to 8m2. Right, now we have to erase to get a little bit more space. We're going to keep that same bottom equation. (72m) plus 8 is equal to 8m2. Now, we can FOIL out the 8 on the left side of the equation, which simplifies it to 8 times m, or times nm plus 1 is equal to 8m2. The equation representing p to the k plus 1 has a factor of 8. Therefore, it is divisible by 8, and we have proved our claim using weak induction.